Hello, everyone, and a huge, warm welcome back to Kognito Key. I'm absolutely thrilled you're tuning in today. We've got a really vibrant explainer lined up for you, and we're going to completely demystify a technology that is, quite literally, silently watching over our planet every single day. It's the kind of tech that helps us predict disasters, uncover ancient hidden ruins, and keep a close eye on the overall health of our Earth. Yep, today we are talking all about remote sensing. So let's just jump right in and unravel this amazing science together. So I want you to look up at the sky for a second. Just imagine these highly advanced devices floating hundreds of kilometers above us, out in the cold vacuum of space. How in the world is it possible that these satellites can gather such incredibly precise, high-resolution details about the Earth's surface without ever actually touching it? I mean, how do they know exactly where a flood is forming, or what specific minerals are hiding inside a massive mountain range? It sounds like straight-up science fiction, right? But it's actually driven by some seriously brilliant physics. Okay, let's dive right into the core of this. Remote sensing is basically the science, and really the art, of observing and gathering information about an object, a scene, or a phenomenon from a distance, completely without physical contact. That word remote is absolutely crucial here. It just means the sensor is located far, far away from whatever we're actually studying. So instead of going up and physically touching an object to measure it, we let electromagnetic radiation do all the talking for us. Now, if that's sounding a little abstract, don't worry at all, because it actually works exactly like something you're using right this very second, your own eyes. Your eyes are, honestly, incredibly efficient remote sensors. They take in the light that's reflecting off the objects around you, and then your brain processes that data into a cohesive image. Or you can think about a conventional camera. A camera doesn't need to physically touch a mountain to take a beautiful picture of it, right? It just captures the light energy bouncing off that mountain onto a digital sensor. Remote sensing from space relies on this exact same fundamental principle, just engineered on a massive planetary scale. To make all this happen, the data capture basically follows a super logical six-step loop. First up, we've got energy emission. Usually that's just sunlight. Second, that energy travels all the way through space in our atmosphere, which is called downward transmission. Third, bam, it hits the Earth. And it interacts with the surface. Rocks, trees, water, they all reflect that energy entirely differently. Fourth, this newly modified energy bounces right back up through upward transmission. Fifth, the remote sensors hanging out in space record that unique energy signature. And finally, step 6, that raw data is beamed all the way back down to ground stations for processing and analysis. It's just this continuous dynamic loop of information. Now, you might be wondering, where exactly are these sensors hanging out? Well, these highly sensitive scanners and cameras are mounted on platforms like satellites, and they typically occupy what's called a polar sun-synchronous orbit. That's right in the 700 to 900 kilometer sweet spot above the Earth. To put that into perspective, standard telecommunication satellites sit way, way out at like 36,000 kilometers. So our remote sensing satellites stay relatively close to home, which is exactly what allows them to capture those incredibly fine spatial details of the surface down below. Now, what's really interesting here is that we basically categorize these systems into two distinct types: passive and active. Passive sensing relies entirely on natural sunlight. It literally just waits for the sun's energy to bounce back from the Earth. It's exactly like taking a photo outside on a sunny day. But what if it's nighttime or incredibly cloudy? Well, that's where active remote sensing steps in. Active systems carry their very own artificial energy source. They shoot their own signal down to Earth and measure the exact reflection that comes back. It's literally just like taking a picture in the dark using your camera's flash. Of course, look, no technology is completely perfect, right? There are always trade-offs. The advantages are absolutely massive. We can map out vast, totally inaccessible areas super rapidly, and it's highly inexpensive compared to sending a whole team of surveyors out there on foot. However, the hurdles are definitely real. Things like atmospheric interference, clouds, water molecules, gases, they can severely modify the returning signals. Plus, the sheer volume of data these satellites are constantly beaming back is just enormous. It requires highly skilled experts and some serious computing power to interpret everything without getting completely overwhelmed. But overcoming those hurdles is absolutely vital because the real-world applications at stake here are just huge. Thanks to remote sensing, we can actually simulate hydrological states to warn vulnerable communities about incoming floods or droughts. We can track the devastating impacts of climate change, we can monitor fragile wildlife habitats, and we can even discover hidden archaeological ruins that have been buried deep beneath the soil for centuries. From engineering and mining to military navigation, the data we are gathering from 800 kilometers up in space literally dictates how we manage our everyday lives down here on the ground. Which really leaves us with a truly exciting thought to ponder. As our sensors get sharper and sharper and our data analysis gets even smarter, what incredible mysteries is space-gathered data going to uncover next? The possibilities are quite literally endless. Well, I really hope this explainer gave you a crystal clear understanding of remote sensing. If you found this explainer valuable and you enjoyed learning with us today, please hit that subscribe button to join the Kognito Key family. Don't forget to like and share this explainer with your friends, and let's keep exploring the wonders of science together. Thank you so much for watching, and I will see you in the next one.